Welcome everyone to another episode of Architect Tomorrow, and I'm really pleased to have Chris Adams back on the podcast. Actually have him on properly, because I think the last time, Chris, you sort of made a brief appearance in one of the Green I/O, one or two of the Green I/O conference episodes, I think. So welcome to being on the podcast proper.
Yeah, hello from Berlin this time, rather than in London actually.
Yeah.
2 years ago, I think, something like that.
Yeah,
Cripes.
that's crazy, isn't it? Because you weren't at it last. Don't think you were at the London one this year, were you? So it would have been.
No, I think it might have been Hannah taking taking that one for the team, rather than me jumping on a train that time.
Yeah. Anyway, for those that aren't familiar with who Chris Adams is, can you give everyone a quick overview of who you are?
Yeah, thank you very much for the time, Oliver. Hi folks, my name is Chris Adams. I am the Director of Technology and Policy at the Green Web Foundation. We're a Dutch non-profit focused on a fossil-free internet by 2030. I also have a background working in a series of wacky environmental and open data themed startups, which Ollie might refer to later on. And I'm also was one of the organisers of climateaction.tech, which is a active, supportive community of climate-focused techies across various organisational boundaries, and that's been running for about, blimey, like nearly eight or 9 years now, actually. So yeah, that's it. I also work as the policy chair at the confusingly similarly titled Green Software Foundation, which is a larger industry body associated with green software and sustainability in technology in general. But that's not the same as the non-profit that I helm with my co-leads Hannah Smith and Michelle Thorne.
Nice one, thank you, Chris. And those who are listening who haven't checked out the Climate Action .tech group definitely should. It's been a really useful source of community and inspiration and knowledge sharing for me. So yeah, folks haven't seen that and are interested in this topic, they absolutely should. And it's funny, Chris, because I think last time we bumped into each other and I recorded you, we kind of reflected on some of that path crossing that we weren't aware, but we were on other two sides of the AMEE thing that you were doing. I was one of the people using AMEE API, and you were one of the people on the team building that. So that's kind of a weird small world in that regard.
Yeah, so that was actually a good example of one of the wacky climate-themed startups. So AMEE stands for Avoid Mass Extinction Engine, or maybe I should say should. I think it might have been subsumed into some larger company now. And I was working at that company in 2011, I believe, right? And I was working as a Ruby on Rails developer there, the kind of clients and community developer. So my job was to build some of the tooling that people might use to kind of build their own calculator, because AMEE had raised a bunch of money to say back in 2008, 2009, where they were actually convinced that we're about to see this kind of shift towards like ESG focused changes in like the industry. And obviously everyone would need to understand and need a dashboard to kind of steer away from disaster, basically. So people like me would be building some of that stuff. So I worked as a developer there, and then I also worked as a product manager there. And that was, this is like probably something that isn't that well known. Back then, this was pre-Node.js. There was a whole bunch of all of the APIs that were served by teaching a bunch of scientists how to code server-side JavaScript, because that was easier than teaching developers about climate science, basically.
That's funny.
Yeah.
And at the time, I was working for an environmental consultancy that had many of the people that were working, many of the scientists that were working on the emissions factors reporting. So so like I say, small world, and it's funny we were both working in the same circle. I then had a period away, and then more recently I've come back, as many people, regular listeners to this podcast will know. Last few years I've been getting back into the sustainability space, and so anyway, the reason I wanted to get you on, Chris, is at Green Web Foundation you've just published a great report on the state of the fossil fuel internet 2026.
Fossil-free internet, yes.
What did I just say? Did I just say fossil fuel
internet? Whoa! That's a bit of a Freudian slip, but to be honest, that's kind of some as a thrust of the narrative inside it. So maybe in face of the data, we might need to change the title of the report in future, depending how things go. But for now, let's go with fossil-free.
Fossil-free, sorry.
Yeah, that was the dream.
Fossil-free doesn't roll off the tongue as much as fossil fuel, right? Unfortunately, I mean, hopefully one day it will. Or we won't need to worry about it because it will be fossil-free. But yeah, and then the subtitle is the Dirty Data Center edition, so it's possibly a little bit indicative of what we're going to be talking about. But So obviously, Green Web Foundation's been championing for many years now to kind of move the internet away from fossil fuel power and to try and move to fossil free.
Mhm.
But yeah, talk to us a bit about the kind of motivations for creating a report like this.
Yeah. Uh, so we wanted to do something like this for a while, right?
Mm.
But the thing is, making reports tends to take quite a lot of time and attention. And if you assume that people should be paid for their time, then money, right?
Yep.
And we actually launched a report a few years before. We've launched a series of reports, but this one was one where we were able to get a bit of funding from to get this together. And we were what the thing that we kind of pitched was basically this idea of saying every year we should be reporting the state of the fossil-free internet and how it's changing over time, because you have a bunch of economic kind of drivers which should make it easier, but you have a bunch of other drivers which are working against all that as well. And the idea behind the kind of somewhat combative dirty data center edition was to kind of come up with a theme and name some of the trends that we've basically been seeing. And whereas like previous we might have been talking about how there's this kind of like mega trend of clean energy becoming just like the bulk of all the power system that we're going to be like moving to. We've in the shorter term, what we've actually been seeing is this massive shift, kind of like the phrase we might use, which I wish we'd actually used, that it didn't occur to me later, was instead of like decarbonisation, it's almost like recarbonisation. You've got a bunch of data centres which are being built with primarily fossil gas powering them now, and that's a change that we have seen. So rather than having a kind of gradual shift away, there's almost been this associated with like this mania for AI. There's been this kind of mania to find something to power it, and that has led to a real shift to what we see as ever larger fossil-powered data centers, which, because fossil gases are kind of really dirty ways to generate power, we're referring to them as dirty data centers, like other people. And that was why we were framing it as this is the biggest change we've seen in the last 18 months, and it's something that we need to be able to be talking about, basically. So yeah, that was the thinking behind it, actually, and I'm pretty sure that gives you a few places to kind of ask on from there, actually.
Yeah. So I guess the AI. I mean, we have to sort of start there. I mean, I guess there's AI, but then there's also geopolitical sort of stuff going on as well that I think are possibly forcing people's hands. I mean, I was shocked to see more stories of coal-fired plants being sort of either extended or brought back into action and all that sort of stuff because of geopolitics. But let's park that for now. Let's look at the AI-driven demand, because I guess and actually before we even get there, I must like to take a step back, because first time I came across Green Web Foundation, I guess your name suggests that maybe it's just the web layer. But when you talk about fossil-free internet, that obviously suggests actually the internet, because obviously the internet and the web, in my mind, of it being a geek, they're kind of two different things. So I guess when this report, what does it look like? Does it look at web, or does it actually look at internet, all the different things that sit on the internet?
Well, this is actually one of the other reasons we framed it the way we did, was because if you're going to have a discussion about the web, right? I mean, eventually you're going to have to talk about data centers, because they are powering something, and well, we could talk about like headers and like interfaces and stuff like that. Ultimately, someone has to kind of run some servers somewhere, and you need to get some power from somewhere. So we initially did talk about basically when I first joined the Green Web Foundation, it was something which was very much focused just at web hosting, basically, right? But in order to actually end up with a kind of coherent analysis of the actual situation, and then come up with some like useful prescriptions, both at a kind of policy level but also as a kind of commercial level, you do need to understand like what's happening at the energy layer and also the data centers. So you need to kind of have a better model of the entire stack, really. So we've kind of had this name for a Green Web Foundation, and we quite like it, and we figured, well, okay, for most people who are not nerds, like say you or me, Ollie, right, the internet and the web, like, they don't really even know what a browser is, let alone understanding the differences between like UDP versus HTTP versus the web versus internet. So we figured, well, we probably will get away, you probably can get away with having a more substantive discussion about the entire stack and about some of the changes, because for most people, that's how they kind of experience all of that, really. They experience the services as just like the internet. And even if you think about the web, when you think about when you're using various tools, like say mobiles to interact with the server, right? The actual protocol is somewhat obscured from you. The fact that you're even using a web view versus something that's kind of native to a system, there is it can become harder and harder to actually say, okay, well, where is the web stopped, and where are we
Yeah.
now talking about something which is definitely just the internet but not the web, right? That is
Mm.
actually quite a bit harder when we're talking about like public services that go beyond a single data center and then have users in other buildings, for example.
So is the just to help the architects listening to this, because we like our specifics, is the boundary line for you then sort of public services, so sort of public cloud, SaaS sort of stuff that in general people can get hold on, rather than any kind of corporate data center? Is the kind of corporate data center stuff excluded from this report, or is it all in there?
For this report, what we chose to focus on was where most of the changes were. And
Right.
the biggest shifts we've noticed over the last few years has basically been at a hyperscale level. So,
Right.
you know, the organizations building data centers the size of Manhattan. That's very different to like a corporate on-premise data center, assuming you're not Meta or
Yep.
Google or
Yep.
something like that, right?
Yep.
So,
Yep.
you know, when we're talking about like on the order of like tens, hundreds of megawatts rather than the kind of tens of kilowatts that you might
Yeah.
associate with like some medium-sized kind of corporate data centers, basically. So yeah, that's what the report is really focused on for this, and that is. I mean, you'll notice it's a relatively short report. It may be that we talk about the corporate side in future, but for now, the biggest change we've seen has been the literally hundreds of billions of dollars and euros being dedicated to these massive new kind of hulking structures that we didn't really have 10, 15 years ago in the same way.
I mean, it's mad, isn't it? Like to talk about data centers the size of Manhattan. I mean, that's just. I mean, I think if you just said that to someone a few years ago, they think you were completely and utterly mad. But yet now we just seem to think that's normal, or that is now normal. And obviously they're kind of measured in the gigawatts, like you say, and people are talking about sticking, 2 gigawatt, 1 or 2 gigawatt kind of gas sort of plant to sort of power those data centers, and that's just staggering. So yeah, I can totally understand why you've gone down that direction. And I guess the other thing, of course, is the web is no longer static. It hasn't been static for some time, right? I mean, it's been dynamic and made even more so by the chatbot, which is what a lot of people think of now when it comes to AI. Or you and I know, and many of the listeners will know, that it's obviously a far more diverse picture than that, different types of AI. But the reality is the general consumer, I think, view of AI now is the online version, which essentially now has become part of the web, hasn't it? So I guess it kind of makes sense to kind of include all of that. So has it been? So it's hyperscalers driving growth. It's AI kind of mania and the craze to just AI everything that's then driving that demand, or are there other sort of underlying forces in there that are kind of creating the demand that's pushing towards fossil fuels again?
So I think, I mean, I think you just need to name it in a few places, right? So if you had a different election take place in 2024, given that we see about like half of the data centers that just installed in the USA, it's likely that you might have seen something which wasn't quite so fossil focused if you'd had like maybe a different president in power who wasn't so actively trying to like kind of put their thumb on the scales to kind of in favor of fossil fuels, for example. So you've had a lot of the kind of policy support that say cleaner energy was having has essentially been removed in the last few years, which has changed it quite a lot. And it may be that you could have plausibly had. I mean, it could be that you might have seen a similar kind of growth because you already did have people having interest in kind of like basically expanding capacity to kind of meet their demand or kind of build their machine god or anything like that. But it may be that people might have been much more focused on trying to do it with clean energy. But the thing is, even building this level of like infrastructure with just clean energy still has like an environmental impact to it. So that's kind of that's some of the stuff that we saw. So yes, there is a kind of like fossil angle, and you have seen a kind of policy environment where people seem to be a bit more keen to use it in the last like year and a half, which has turned out to be not a brilliant idea in the face of like the Straits of Hormuz and stuff like that. People realizing that actually there are actually all these other downsides beyond climate associated with fossil fuels because they're volatile, they can be incredibly expensive, and in addition to being like polluting and having a massive kind of like local effect as well as like a kind of global effect, really.
well, you've touched on the geopolitics stuff that I kind of parked from earlier, but like, yeah, I mean that's obviously a very point in time thing at the moment, and I hope by the time this episode airs that the Strait of Hormuz thing isn't such a live issue, because there's human lives and so on at stake as well, which I don't want to sort of trivialise by talking about sort of some of these other things which seem by the grand scheme of things not significant. But that said, it is interesting that things like the Strait of Hormuz and the sort of second and third order impacts from that are getting people to look at potentially coal, because where you live in Germany, there's I know this because I used to work for a German energy utility. There's a huge amount of brown coal of lignite, which they literally demolish villages and towns to get access to. Right?
There's a giant Garzweiler thing. Yeah,
and so unfortunately, yes, while they can be highly volatile, there's also still quite a lot of them in the ground that we could start digging up and start burning. And yeah, it's disappointing, isn't it, that we're kind of going down that route. But anyway, I don't want to get too doom and gloom, because I actually think one of the things I really liked about your report is the maps and the visuals in it. And one of the things I think people don't quite appreciate is quite how many data centers there are in the world now. And I think that was one of the nice things about the report, is it's kind of bringing that to life and showing people literally this is pretty material now. We've got nearly 11,000 data centers globally, a big concentration of those in the US, quite a lot in the UK, interestingly, isn't it, that we're probably number 2 by the looks of things from the numbers from the report. But it's growing. I mean, where do you see, I suppose, where does the report suggest the most growth is coming from? Is it from Asia now, or is it still the States and Europe that dominate?
So if you look at the pipeline of data centers that are that people would like to build them, you still have by far and away the US as where you see like hundreds of gigawatts of data center capacity of projects worth of data centers. Data center capacity worth of projects planned in the coming in the coming years. Now, it's worth being clear that not all of them are going to get built for all kinds of reasons, because it turns out that lots and lots of this is really, really speculative. But you still basically see most of that in the US right now. Europe is somewhat smaller, and there's kind of limited information about China, for example, because the actual data source that we work with, the people who provided that data center map, the main thing they do is they show data centers where you can purchase co-location, and for most of us, we're not going to be setting up a data center in China tomorrow, for example. So therefore, that's not going to be so visible. So that's one of the artifacts of this. So yeah, you do see all of them. There are lots and lots of these buildings around, but the key thing to bear in mind is that there's been a real step change in the size of these buildings in the last 18 months to 2 years, whereas previously we'd have said, a 25 megawatt data center is a medium sized, maybe quite a large data center. But when you have people saying, we're going to have a 100 or 200 megawatt data center, or in the USA, you have someone saying, I think it's the Monarch project, which was, we want 9 gigawatts of offsite gas, then that's qualitatively different. That's a totally different thing, because that's for context, if the UK in the parliamentary inquiry, when politicians were trying to make sense of this, that inquiry, the briefing for MPs said, we've got about 1.6 gigawatts of data center capacity in 2024. So when you look at one project being multiples of that just in its own right, that gives you an idea of how much of a step change we're looking at here.
No, that's crazy. Totally crazy. I wonder whether this report is going to get harder to produce, though, because it feels to me like the internet is somewhat fragmenting. The vision of a global internet, as we've sort of thought about it, as we've kind of grown up and had our careers, it does feel like it's starting to fragment, right? Like China increasingly has its own sort of thing, Russia, other states. So I do wonder whether actually producing a report like this is going to get harder, because this concept of a single sort of internet is possibly sort of fragmenting. But anyway, that's possibly a little bit of a before don't want to spend too long on that, but any kind of thoughts on whether the internet is fragmenting along those sort of geopolitical lines?
Kind of. I suppose we got limited visibility into, say, in the internet in China, for example. There is that, and there's maybe somewhat limited information about what you might see outside of maybe North America and Western Europe, where you can have much better information, because that's where there's a lot of commercial activity that I guess a company like Data Center Map is actually providing. But there are other sources of information out there, and it's also that other entities are kind of keen on transparency or sharing some of this stuff. Like there is, I think it's. I mean, the other thing to bear in mind is that there are different ways of detecting data centers, right? So it may be that this stuff actually just gets published in other parts of the world and becomes much easier to find. So we'll see. Like we haven't written off on the idea of like a global internet just yet, and hopefully that even maybe with changes in power, you might have a kind of shift away from kind of regional rivalry. You may, we could see the pendulum swing back away from the mania around sovereignty that we see right now, for example, or not, maybe not sovereignty, but like let's just use sovereignty as the kind of the nicest sounding term for it right now.
Yeah. And I guess ultimately, even if it does fragment, you can always use things like Earth observation data to go and find data centers from geospace.
If they're getting bigger, they're going to be easier to find.
Yeah. Cool. All right. Well, what was the sort of biggest surprise for you in pulling this data together?
I think the biggest surprise was just how much the change in size was, because as an organization we've been talking about a fossil-free internet for a while, and we've been primarily just saying we've made a kind of point of focus, or previously we would talk about where the energy came from, because that felt like one of the easier things to solve. Like data centers aren't flying around, right? Or for the most part, they're not. Yeah. So so therefore you can plug. They should be easy to power than other kinds of things that need to be decarbonized and are quite difficult to decarbonize, like say planes or ships and stuff like that. So we thought, oh, this would actually be at the beginning of the 2020s. We thought, oh, this is a relatively easy thing to decarbonize. But the kind of increase in energy density and the increase does change the situation.
The concentration and the sort of scale is a problem, isn't it? I mean, like, it's one thing when you've got, like you say, the kilowatts and the megawatts. When you start getting into gigawatt, that's just kind of crazy orders of magnitude harder to start. Yeah.
And like I kind of feel one of the reasons people are doing that, or even asking for that, is because they're not quite sure how difficult that is to build, or they've just underestimated how hard everything which is not computers is. And what we're seeing right now, actually since we've published the report, we're seeing that actually lots of data centers, even the big ones, aren't coming on at the speed that they thought they would, right? You're seeing maybe a 1 gigawatt data center might be maybe only 100 megawatts if it's actually delivered at this time, and they're really struggling with the other ones because it turns out to be really, really difficult to do this stuff. And it turns out like the limiting factor isn't always like the number of chips you can buy from Nvidia, for example. There's all these other constraints that people have underestimated.
Do you know what that neatly brings us on to, like, point number 3 that I was gonna come on something else, but let's move on to point number 3, which is this sort of Anthropic deal at the moment to use all of Colossus, because this sort of neatly talks about this sort of scale problem, right? Like the Elon Musk made a big thing about pulling out all the stops to, if you like or loathe the guy, is immaterial, but what he managed to achieve was, or collectively his team, pulling together Colossus in record time. Now, clearly there are significant issues with the way he chose to power that, or the company ended up powering that with something like 30 odd methane turbines without.
It's amazing
permits.
How fast you can move if you are prepared to ignore all of the laws
that
apply around you, right? Yeah, because like that was literally the reason they were able to do that so quickly was basically by ignoring a bunch of laws, right? So that's like, I mean, that's one of the things that we've seen documented, and this is one of the problems that we now see here. Basically, is that that gets you some that you can move maybe quickly for a little while, but this stuff will catch up with you.
And then what's interesting for me is because they broke those laws and they just did it. They did the JFDI approach. They're now probably one of the only ones that actually has an operational, capacity of that size. And so then you have, Anthropic taking the lead in terms of adoption and actually making money, and running out of capacity. And so who do they turn to? Well, they turn to the one organisation that seems to have managed to, pull off for the reasons we just described. And so. I just wanted. So that seems to be what's happened, but I just wanted to kind of get your take on this. Was it a big surprise to you? Because for me it kind of was. Like Anthropic, in my eyes, were always sort of seen as hopefully the slightly better flavour of AI than some of the alternatives. But it just, did this surprise you? What's your sort of take?
I mean, this came up because so we're doing one thing with the Green Software Foundation, the Green Web. What we're doing right now, there's a standard that we're developing called Software Carbon Intensity for Web, and it's a bit of a wacky approach to create a standard, which is largely you have a bunch of people, rather than being on video calls every week for an hour at a time and then arguing about things. The idea is that you've got a kind of approach where you have a series of questions being asked. People are responding in written form, usually via email, but not always. And then they're all being sent. Everyone's takes on these questions, which are kind of designed to kind of help shape the spec. They get synthesized into what ends up being like a pull request to the existing spec that we have. And over time, over a series of weeks, this spec is basically supposed to be built out over time, right? And so you've got a weird kind of like LLM mediated approach, which is kind of interesting and probably a podcast in its own right. But the thing is that was been using Claude, like Haiku and Claude Sonnet for a bunch of this stuff. So this was immediately like at work we don't use Claude's tools, and and I've used kind of Claude myself personally. I thought, okay, well if I'm aware that it's very, very useful service, and there's lots of people who get lots of value from this. And then when I read about basically Anthropic saying, we've decided to expand into the data center in a sacrifice zone, that just made me think, oh god, that's now we've got a sacrifice zone in the supply chain for a project that we're actually involved with the Green Software Foundation, for example. And that's something which was honestly doesn't leave a good taste in the mouth for us, and I don't think it does for other people, because when you associate AI safety, you assume safety for everyone rather than just the people designing AI, right? And this is the thing, and when you're choosing to have a data center which is sited in a place which has had decades of environmental justice issues and people having shortened lives because of all the other issues around it, there is it's not a good feeling, and and honestly my emotional response was, how the hell do you get out of this? This is definitely not anything I want to be associated with, and you probably should have this. Really, this should actually be solved in another way, but in the short term, you definitely do not want it in your. You definitely don't want it in your supply chain, basically.
No, I'm there as well. I mean, I've been a pretty, it's fairly clear from a lot of my stuff. I kind of declare the use of Claude in a lot of my work, and I'm very much caught up in this whole thing right now. Is what do I do, because it's a very capable platform, but equally I can't be duplicitous.
So there are things you could do, right? And and this is what I actually looked into, and I posted this on. Oh jeez, I posted it on LinkedIn because that's what you have to do now. If it's like millennial Twitter, or before Twitter became a bit of a Nazi bar, right? Or okay, so but the key thing was that I'm unable to even you got say one person who might be considered a kind of, although he doesn't say it himself, a pro AI data center kind of commentator, Andy Masley. The quote from him was, "I would simply not run my inference out of this data center," right? And then you look at this and think, okay, how do I actually do that, right? And it's not something which is particularly easy to actually do. So if you look at, say, what does Claude offer in terms of how much control do they have for routing requests around, they basically have two options, which is global or US. Now, neither of these are addressing the issue when you are looking through the options in the kind of Claude system, right? However, there are steps you can take, and there is one company there's one product company called Modiac, which is from the people who built GreenPT. Okay. They basically looked at this and thought, well, we know that there are different places, like Amazon runs their own kind of AWS Bedrock instances, and we know that Google is also in Anthropic's supply chain, right? So if we know that some people are running this in Europe, there are options where you can say, I'm only going to run Claude inference inside Europe, for example. The flip side is now you're paying full top whack for the API rather than whatever kind of subscription you had before. So you're not going through the kind of through the main door, basically. So exactly. So that's the flip side that you have, and also this feels like a really, really shoddy situation to the problem, basically. So these are some of the issues. I mean, there is a wider issue about if you're someone who's if you're like at the helm of Anthropic, you've made a deliberate decision to say, well, okay, of all the places I'm going to go, I'm just going to accept that rather than say that, oh, I've just managed to land all these projects with all these other providers of compute, like with Google and Amazon and everything like that. The fact that they've said, no, I want this now, and I'm moving into the sacrifice zone, that says a lot about the company and about the decisions that are happening at a product level there. And I kind of feel this is something that, honestly, if we're like responsible technologists, we should be seeing what people are doing here, right? And we should be and we should be listening to what they're doing, and thinking, do you want to be part of that supply chain or do you not? Or if you don't, then have you had that conversation with a rep or someone, or is there a mechanism for you to say, can you please not run the data center in the sacrifice zone? Because this just feels like there's a bunch of environmental and racial justice aspects which I think are really, really like literally toxic, and we do need to. And if we're acting as people who are architects designing these solutions, then we do need to be prepared to engage with these issues and think through what the options are to either mitigate them or just not be there in the first place, for example.
Yeah, I mean, this ties in really nicely with a piece of work that the architectural community has done, actually, which is these regenerative architecture principles. And it very much speaks to, as architects, yes, we may not have ultimate say. That's often senior stakeholders that sign off on decisions. But that doesn't mean you can't surface up the issues and the trade-offs a bit more explicitly. So, and this is where the sort of second and third order impacts kind of come in that we touched on earlier. Like, yes, you're purchasing an AI service, or you're kind of choosing a hyperscaler hosting solution, going back to your report for a moment. You have choices there, and they aren't necessarily always have to be driven by cost or by functionality. There are other second and third order impacts that we need to start thinking about, because if we don't, then what kind of world are we sleepwalking into that we're not consciously kind of making some of those decisions? And I think in a world where technology is increasingly perhaps eating the lunch of the technology architect, where a lot of that sort of more heavy lift is being done by the AI, well, what's the role of the human in that architect equation? I would suggest it's to be conscientious and be human and think about the judgment and the decisions that need to be made. So it's a really interesting point that you're making about kind of being more conscious about those choices, because I think I speak to, unfortunately, too many people who just don't think A, that they can voice them, or B, that they even know that it's a thing that they should be thinking about. And I honestly think people need to sort of get more informed on this and start thinking a bit more conscientiously.
So the thing I shared on the post was basically, yes, there's this whole moral angle, but I totally get that most people don't get paid to be the moral compass of their company, right? So the framing that we were talking about was actually brand safety, right?
Okay.
So that's like a thing that you're able to say, like, okay, these folks, if we're going to talk about we're going to be leaders in responsible AI here, all right? Yep. There is nothing responsible in operating a data center out of a sacrifice zone. And if you are now associated with that and you don't have a good answer other than, oh, we're stuck now, that doesn't really speak well to your abilities as an architect to kind of design against this, right?
Yep.
And I mean, the example with, say, the Green Software Foundation, the conversation we had that actually is on a podcast and recorded, is basically saying, well, okay, what are our options if we know that the system is designed that we're using for this kind of standards process that is using an LLM, is using a specific model, but are we absolutely entirely tied to that model? Is it possible to use? If we just want to only stay inside big tech, does that mean we switch to Google Gemini? Does that mean we switch to Quen or Kimi 2.6 or something like that? Do I have other options? This is if you're prepared to have a conversation about where this is coming in or where your integration points are, then you've got an idea about, okay, how exposed am I to decisions like this? And if I don't have that much influence over them, at least I have a way to migrate to something else that is actually more aligned with the kind of values that we want to be, we either express in our brand, or we have as humans working in a company and feeling a particular way about wanting to bring all of themselves to their day job because it's taking up most of their life. And if you're going to spend 40 hours a week doing anything, it better be good, right?
Yeah.
So yeah.
Yeah, I mean, I'm with you. I just think, unfortunately, the geopolitical climate sometimes doesn't allow people to think that way. Because, anyway, let's avoid that rabbit hole. And Let's jump across to the SBTi decision, which is or ongoing lobbying that's kind of going on, because that was the other bit of news I was really keen to talk to you about. So perhaps to start with, for those that haven't been following this, because I'm sure not everyone is like you and I who've been following it, what's your sort of summary on what's been going on with SBTi and sort of Scope 2 greenhouse gas emissions?
So so if I talk about like GHG protocol and Scope 2, can I assume people know what that means, or shall I just...
Let's quickly recap what Scope 2 is. I think most people probably do, but for those that don't, let's quickly recap what that is.
All right, so the standard way for any organization to report the carbon footprint of anything at a corporate level is this corporate standard, and they talk about things in terms of Scope 1, 2 and 3. And on a podcast, the easiest way for me to explain that in a kind of informal way is to talk about coffee or hot beverages, right? You can think of Scope 1 as you making coffee by burning gas or burning wood on a stove to heat up water so you can have your hot beverage, right?
Yep.
You can think of Scope 2 as you using an electric kettle to heat up water so that you can have a cup of coffee. All right? You're not burning it yourself, but someone is burning it on your behalf. Scope 3 is you walking into like some hipster coffee shop and you pay someone to give you a mug of coffee so you can have coffee. So there's a supply chain, but you're not actually you're only experiencing the kind of thing at the
product
end, basically.
And the service. Yeah.
So Scope 2 is all about the electricity part, and the thing with the science-based targets, this kind of standard they have, is that there are two ways of talking about the Scope 2 part. So you can talk about the location-based carbon intensity of power, which is essentially how much coal and gas is burned for you to get power out of the socket that you use in a given like city or part of the world or anything like that, right? Now, that is one way, which is physically like quite a rigorous way of looking at this. But there's another approach which is market-based, which is saying, well, yes, there's a carbon footprint associated with the power that I've got. I don't get to control it directly, but I do get to maybe buy from a green supplier, or if I'm at a corporate level, I do get to procure energy from a solar farm, even if my connection is to the grid rather than directly to the solar farm, for example. So that's kind of what some of that was about. There's market-based and there's location-based. And the thing that we've had over the last 10 years is that the market-based approach has been based around an annual basis for carbon intensity. Has been based around annual certificates rather than hourly certificates. With the
overall consumption that you've consumed in a year is essentially is what we're operating at, rather than more granular than that.
Yeah. So that's the idea. The idea would be that it's the model that you have is like over an entire year, maybe you've used, say, let's have a nice round number of maybe 100 megawatt hours of electricity consumption that's powered all your data centers and everything like that, right? Now, it could be that the previous system would be that as long as you can demonstrate that you've bought you have 100 megawatt hours of certificates for that over the year, that's fine. You get to call it green. And like that sounds fine until you realize that means that you could just buy a bunch of solar of certificates from solar farms, and then just kind of apply that to a bunch of fossil generation from like coal and gas-fired power things, which means that you're essentially saying all of my power running at night is green because of solar. And most people don't think that solar works that well at night. So there's like a kind of, you're stretching the plausibility of the scheme, right? Yeah. So an hourly system has moved to this, saying, well, no, you can only match this with power that's been generated at the same time as the power you're consuming. So if you wanted to have something at night, you would need to be either pairing it to wind, or you might need to pair it to solar that's been stored in a battery that is then discharged at night, for example. And that is more complicated than just buying a bunch of solar, buying a bunch of solar and saying, oh yeah, this is my job done, basically.
Yeah, I mean, it sort of smells of greenwashing, and I think this is why I suppose the hope was that the rules would get changed to be a little bit tighter around the reality, because there's terms that get thrown around in sustainability like consequential and material and attributional, and essentially what they've been doing is being able to report or attributionally say that they're green, But the reality is the consequences is that they have actually been consuming, kind of energy from a variety of different sources, not just renewable. So personally, I was hoping that the rules would get tightened. It sounds like the tech industry has managed to lobby successfully at the moment for those rules not to get tightened.
So there was two things that's probably worth being aware of, right? Now, my understanding with the SBTi thing was there was one thing about this hourly thing where there was a whole fight, and there was actually a campaign called May Not Shall, which refers to the idea of saying, consumption may be matched with hourly or shall be matched with hourly. One of these is much tougher than the other, right? So that's what you had, and you basically had, I think it was like Amazon and Apple and Meta pushing for this may not shall thing, so that they could use the kind of not very plausible way to match things, because it's way cheaper and it's way easier, and you don't really need to think about complicated questions like, okay, do I now need to just actually have, rather than just buying solar, I now need to think about a portfolio approach. So yeah, my energy team has to buy wind and solar and batteries, and there needs to be some way of actually matching these things together, right? So that's the thing that's more complicated for people. But it turns out that using power all the way around, if you're going to make a claim, then you do need to be prepared if it has to be plausible. And the whole point around science-based is that it's supposed to be following the science, that you have this. So that was one of the things.
Yeah. Go on. So you're going to go.
Yeah. The other thing was that, and this is quite a bit more nuanced, is that there was a shift from zero carbon to low carbon. Talking about this, that was another thing that was named, and I know that you shared this in the kind of show notes before. And it's the actual details. The main reason you have this is that is that when people talk about the kinds of power that you have, there is the idea previously was that you might have a shift where zero carbon would mean renewables, solar and nuclear power, things like that, things which definitely do not generate carbon dioxide when they're emitted, right? The shift to low carbon was intended to allow people to basically burn fossil gas but use carbon capture and storage, right? Now, there is all kinds of things which are problematic about burning the gas and whether how effective CCS is. I mean, Google actually they're now funding a CCS facility. I think it's in Chicago. So like even Google is now looking at this, right? But the key thing that's like more to take that's not the reason that people are always pushing back against this. One of the reasons people push back against this is that if you're looking at gas as one of the mechanisms for generating power, gas causes damage and like pollution all the way up to the point that it's being burned, because you can get your gas from certain places, and because methane gas is like at least 60 times as powerful as kind of carbon dioxide. That means that you can actually
as a greenhouse gas.
As a greenhouse gas, So basically, you can have this thing where a little bit of gas leaking in through the pipes, or even when you've actually kind of got it out of the ground, if any of that leaks as fugitive emissions, then that can be much worse than the actual problems than the combustion impacts, basically. Right. So that's one of the things they're taking into account here. And like previously, and there's various other standards, like the one from the climate group. They have one which says 24/7. The 24/7 carbon-free approach basically says no, even if you capture all the carbon emissions, because there's been damage, because there's been global warming and pollution happening on the way through the supply chain, we still do not accept it. And this shift has said, oh, now we do accept it, because we are essentially discounting, we're ignoring the emissions that happen through the life cycle now. So you've had some people refer to the science-based targets as the surrender-based targets initiative now, because you basically see this change here. So it's not necessarily about the burning, it's about the entire life cycle, because that can have a massive impact depending on where you get your gas from.
Yeah, no, absolutely. The life cycle is really important. Otherwise, we just sort of zone in on one thing and miss the bigger picture. One thing I didn't get a chance to look for is embodied carbon considered in the report, the state of the internet, fossil-free internet report.
So previously, we've been talking primarily about energy. And we talk about the fact that there is an embodied environmental aspect to building anything, right? We do talk about that because the report A is our first one, and we're trying to keep it. And there's quite a lot to actually introduce to people. We've focused primarily on the energy side,
On the operational side, yeah.
Yeah, because
Yeah.
that's the thing that is the easiest one for us to. I mean, that's the thing where you're seeing the biggest shift right now, from something which was
No, I get it.
relatively easy to decarbonize
Yeah.
to something which is way harder.
Which made it harder, and
Yeah.
I guess it'll be a nice problem to have when we've dealt with the operational electricity use, and we're now talking about the buildings and the embodied carbon in concrete and steel and things like that in the data center.
I mean,
so that
proportionally also over lifetime of lifetime of a project, the actual emissions from burning the fossil fuels is still much larger than particularly with the data centers. Like if anything which uses a lot of energy, then and data centers, it's like at least 3/4 is going to be from the actual energy consumption rather than the embodied emissions from creating it. Like they're still there, and it's still something you need to address, but we have relatively clear solutions to the energy part, whereas the solutions you might use to achieve the high levels of temperature needed to turn sand into, say, a silicon wafer, that's something which is not so widespread at present. There are options out there, but they're not really adopted inside the technology sector yet.
So these things we've just been talking about, do you think they're the major barriers for getting to a fossil-free internet, or are there other things that you think are significant in order to get there?
We talk about three things in the report. We talk about managing the demand, because if you want to, let's say you've got a fossil-free internet which uses 100 terawatt hours of power of electricity, right? If you double it to, if you say it's using 5 times the demand, then you've got 5 times the energy to decarbonize. So like that's one. Really simple, straightforward.
So manage your demand.
Yeah, manage the demand was one of the things we said. We talk about green the energy, because you don't need to run things on fossil fuels. Even Google is now demonstrating that they can run a data center without fossil fuels. There's a really good example in Illinois where they've basically built the biggest battery that from iron air instead of lithium and stuff like that to do this. And the final one was actually about democratizing tech. So we talk about 3 levers, because you can't just look at one, basically. And the democratization of tech is explicitly a reference to the fact that we've basically seen an industry become very large, and where you have a number of very small, a small number of extremely large players who have incredible access to policymakers right now, and as a result, they are essentially shifting policy to fit their needs.
There's like regulatory capture going on.
Yeah, exactly. So that's what we speak about in the report.
I mean, you're speaking my language there, because seen for the last couple of years, I've been trying to bang the drum for there is more than one way to architect AI, right? We don't have to use big centralized data centers. Maybe for training models we do, because it's easier to train models in a big centralized set of GPUs, but for running, increasingly we're seeing, and I think the Chinese are sort of, going back to China for a moment, the Chinese have shown with their innovation that their constraints, they don't have access to the same state-of-the-art chips that other parts of the world do. They're having to do more with less, and therefore they're showing that you can start to run some of these models on more modest hardware, and people are running things on Macs and on consumer GPUs, and I think it's sort of one of these things where I use the analogy of, we started telling the time by looking at clock towers, then we perhaps had big grandfather clocks, and then over time timepieces got miniaturized, and now we walk around with them in various different places on our wrists and our phones and what have you. And I do think that AI is probably on the same sort of journey, and my hope is that actually it reduces its power consumption, becomes more frugal, and that power demand becomes more diffuse. So that kind of helps us with the decarbonisation sort of piece. And I know you've spoken a little bit about this in the past, so wanted to sort of, is that what you're kind of thinking about? We kind of decentralise some of where this is run, and it's run more by the end user, or are you thinking something else?
So I was kind of referring to the fact that if you're a company, that this idea of having multi-hundred megawatt, tens of gigawatt data centers is very much a kind of like US thing, right?
Bigger is better.
Yeah, it's kind of very much, it follows this idea that what the thing we need to do is scale everything up in a way that's very centralized. I don't think, I mean, if you just look at like the strategies you've taken, I mean, let's just look at China, for example. China's AI strategy isn't about building massive proprietary foundational models which are then sales access to everyone, and basically where you basically have a small number of companies able to define how they use them, right? In China, for example, there's 2 things. First of all, the AI strategy was basically saying we're going to create lots and lots of open source open source models that can be like integrated into any or various activities you're doing. All right.
Yep.
So
Yep.
that implies a different kind of, and like as you said, because you might not have access to really, really powerful chips. So therefore, a flip side of that is that you design it in a way that isn't necessary. It doesn't need huge data centers in the same way. But also, they've got a whole like different policy environment. Like you literally aren't allowed to use AI to fire people in Chinese law, right?
Yeah.
So that's going to change like society's response to this. If they know, oh, this is coming in to help my stuff become more efficient, and rather than with the efficiencies, they're going to reduce headcount, but we do more things and do more kind of useful stuff. That's a very, very different framing to how you see AI sold to lots of people's bosses, particularly in, say, like let's call it just the West, right? Where like this thing means you get to halve your headcount. That's essentially the thing that how it's been presented. And if that's taken off the table, then you've got a very, very different discussion. And then if you don't look at China, let's look at the most populous country in the world, India. India's entire thing has other uses of AI, where there's a whole push for on-device AI that works in all the different languages, where you've got like it's still NVIDIA working with stuff, but they have a very, very different model, which is not tied around sending all your requests to a massive data center that may or may not be in a sacrifice zone, as we're learning now, right? So there are all these like decisions that people have been making that go beyond just are we going to have AI or not, for example.
Yeah, no, that's great. I mean, and I think for the primary audience of this podcast, it's making people aware that there are choices out there around how you run your AI. You don't have to go down the hyperscaler route. There are, there's Hugging Face, there's whole open source communities. There's other architectures that you can deploy your AI in. Cool. I knew we'd end up on AI because every conversation at the moment, unfortunately, does, and it is one of the big things powering the demand in your report. But Chris, before we close, is there anything, I suppose, that's giving you kind of optimism and hope that the fossil-free internet is achievable, and perhaps in a few reports' time there'll be some good news stories?
So, I mean, what's the phrase that Kim Stanley Robinson once shared? He said, "Angry optimism." Right? This idea that there were two kinds of optimism. There's a kind of cruel optimism where you think, like let's talk about the kind of like AI safety, like. Isn't it going to be awesome that Claude makes my life really, really easy, and I can be really optimistic about my life without really thinking about, okay, what's the human cost of that, right? And then there's angry optimism, like, yeah, this is awesome, but I'm angry that I need to fix these other parts, right? So that's kind of like the framing that I find that source of, if not hope, then maybe something which drives me. Drive, if not hope, is maybe the phrase I might use. But I think some of the big changes I'll probably see is, honestly, this massive and unexpected thing that I've seen in the last like 3 years, or the last actually in the last 5 years, has just been this massive shift in the economics in how you power things, right? If you look at 2022, which isn't that long ago, when we had an energy crisis in Europe when Russia invaded Ukraine, you had this thing where we had an energy crisis and we didn't really have access. Like batteries were still way more expensive than gas. EVs were still massively more expensive. But we're having an energy crisis again, which was like entirely unforced energy crisis, right? Which is causing all this harm, all this avoidable harm all around the world. But the thing you're seeing now is people thinking, oh wow, I now see fossil fuels as something which is really, really volatile and unreliable, and now I'm prepared to look at other options. So you see, like, and now like in 2026, like, are you in the UK, dude? Like, the average cost of an EV is lower than an internal combustion engine car. Like,
certainly in the second-hand market.
Yeah, it's like we now have this thing where we actually have a switch. No, I'm not sure if that was a second-hand. I think it's actually, when you look at it and you take into account the actual the average cost of a new car versus it
has reached close
parity
close
now.
to
So that was like 4 years
yeah.
ago.
Right.
And then in other places you're seeing this massive shift away from fossil fuels. And the thing that is different from fossil fuels compared to like clean energy is that as you buy more of this stuff, it gets cheaper because of Wright's law. So you end up with you end up with a kind of shift inside this. So I think that's the thing that makes me feel
Oh,
optimistic
that's a
about
really
this.
interesting. That's a really interesting framing that I'd not thought about, which is fossil fuels are only ever going to get more expensive as they get harder and
Yeah.
harder to extract. But actually, renewable technologies, notwithstanding the access to the materials, but then in fact there's quite a lot of, there's a good circular economy story there on reusable materials. In theory, renewables just, and they've been shown to, the cost of a solar panel, the cost of other things and batteries and so on has gone down. So if anything, renewables is just going to get cheaper and cheaper whilst fossil fuels gets more and more expensive and more volatile, to your point. So I do wonder whether this year is a tipping point where people start to kind of, that becomes more of a mainstream accepted concept.
Dude, batteries is like 45% cheaper this year than last year.
Wow.
And it was 45% the year before, or if it's something along this. There's figures here. Like these are like this is just totally changing the shift in economics is one thing. So that's like that's like one thing that's driving. But the other thing I'm seeing is just like, honestly, I mean we're both in the tech industry. We both enjoy playing with tech, but that doesn't stop me just marveling at just how ineptly all the people building data centers have managed this entire public discourse, where basically they've been able to piss off everyone, right? Like, this means that like you're going to have to see changes take place. So like you have people proposing moratoria right now all around, like in Europe, in the US, and that's seen as like an actual meaningful policy decision because things are so egregious as they are right now. So I do feel like things, I mean, I do think that the conditions are ripe for, honestly, people who got involved in tech because they actually see that as a kind of liberatory, kind of positive thing. There's a chance to kind of like, still fight for that rather than say, oh no, all I'm going to use technology for is basically just consolidate power and return value to a small number of people. I think there is a shift that means that no, that you don't necessarily have to have it like this. It's just that we've gone through a real difficult phase, particularly in the last couple of years.
Well, Chris, look, it's always fantastic talking to you. Great to bounce ideas around, and this we've touched on topics which were entire podcasts of their own. So maybe in the future we can kind of revisit some of that. But it's nice to sort of leave on a reasonably kind of optimistic note that there are levers here, there are kind of market forces that should drive things in the right direction. And so with that, thanks so much for coming on. Thanks for your time.
Thank you for having me, Oliver. Take care.
Awesome. Thanks, Chris.